Maximum power transfer. Now we're considering the previous circuit, DC circuit, where we have a steady current I that flows through the circuit. The battery has electromotive force EMF epsilon, internal resistance R, and we have a load resistance capital R. Find the load resistance capital R for which the power delivered is maximum, and what is the maximum power delivered. Now, what is the power that is being delivered to this load? It's the power dissipated on the resistor P sub R, which is I square R, as we have shown. And the steady current that flows through this circuit is the electromotive force epsilon divided by the total resistance capital R plus the internal resistance R. So this is I. Now we take this square, multiply it by R. So we're looking for maximum power delivered to the resistor. For PR maximum, we will require that the derivative, the partial derivative of the power delivered with respect to the load resistance should be equal to 0 because it's an extremum. So let's take this partial derivative. All right, so we have del P del R. This is partial derivative with respect to load resistance del R of epsilon square R and capital R plus internal resistance lowercase r to the power minus 2. So we're ready to take the derivative with respect to capital R. So the first term, this is a product of two functions that have capital R in it. First term is epsilon square capital R plus R to the power minus 2. And then the derivative of R plus capital R to the power minus 2. This will give me minus 2 epsilon square capital R plus R to the power minus 3, and we set this equal to 0. We're looking for the value of capital R. So I divide this equation by epsilon square. The epsilon squares will cancel. Then I will get rid of capital R plus R to the power minus 2. So I multiply both sides with capital R plus R to the power plus 2. So this will disappear. And this minus 3 will become minus 1. Okay, so we will be left with 1 minus 2 capital R, R plus capital R to the power minus 1. So we have 1 minus 2 capital R plus R to the power minus 1 is equal to 0. Now I'm going to multiply this equation with capital R plus R so that I will have capital R plus R minus 2R equals to 0, which will give me R is equal to capital R. So when this condition is satisfied, the load resistance is equal to the internal resistance of the battery, then we will have maximum power delivered. Now, what is the value of the maximum power delivered? Then we have P max is equal to I square. So I is epsilon divided by R plus capital R, but they're equal. So epsilon divided by 2 capital R parentheses squared. this will give me epsilon squared over 4 capital R squared multiplied with capital R, and I will find the maximum power delivered to be epsilon squared over 4 capital R, or epsilon squared divided by 4 lowercase r, which is the resistance of the internal resistance of the battery. So this gives me my final answer. And this result, the fact that the maximum power is delivered to a load whose resistance is equal to the internal resistance of this battery that it is connected to, is basically called the maximum power transfer theorem. So this is in general true when you consider any circuit that has an equivalent resistance R. The load that will be connected to the circuit should have exactly the same resistance for maximum power transfer to occur. Okay, so what have we done here? We considered a DC circuit where we have a battery that has electromotive force epsilon, internal resistance R, connected to a resistor, load resistance R, capital R. And under steady state conditions, what should be the value of load resistance for which the maximum power will be transferred, and what will be the maximum power delivered to the load? The power delivered to the load is the DC current I square multiplied with capital R, and the DC current I, as we have shown previously, is basically epsilon over capital R plus R. So that's the total resistance in the circuit. So I take it square multiplied by R. This is the power, but for this power to be maximum, we need to take the partial derivative with respect to capital R and set it equal to 0. When we do that, we find that when R is equal to capital R, when the load resistance is equal to the internal resistance of the battery, we will have maximum power transferred. What is the maximum power delivered to the load? It is the current epsilon divided by 2 capital R parentheses squared, epsilon squared over 4 capital R squared multiplied by R, epsilon squared over 4 capital R, or epsilon squared over 4R. And this is also known as maximum power transfer theorem. Capital R, the load resistance, must be equal to the internal resistance of the battery for maximum power transfer.